Yeah.
Okay.
Okay. Is there an order that you prefer, like starting from the nose cone and following the rest of the rocket, or we can follow the technical report?
I'll go in any direction you prefer.
Okay, fine.
Okay.
So,
Yes.
So vamos começar pela coisa. So let's start with the tip, the nose cone, and following the rest of the rocket.
Okay.
Set it up.
so my name is Lucas Paredes. I am the leader of aerodynamics, and I will be showing you the nose cone of the rocket. It is made of fiberglass with resin, and the tip of the nose cone is made of aluminum, as
Okay.
you can
Good.
see. The format is a von Karman solid, revolution solid, and it has around 50 centimeter. That is like 25 inches, I think.
Okay.
So that's the
Yes.
nose cone of the rocket, and the tip goes right here.
Okay. Very good. It's, it looks like the nose cone tip is a little bit large.
Yeah,
Yes.
because
Is that going to be pared
yeah,
down some?
we just get the nose cone out of the mold, so
Oh,
we have
okay.
to do a little bit of sanding and finishing, but the final result will be pretty,
Like perfect, like
yeah,
even.
even.
Perfect. Well, excellent. It looks very good.
Yeah.
Okay. And after that,
So
yeah.
the next part of the rocket is the payload module. Isso
Ah,
ia,
yes.
ia chutar muito. So do you prefer that we show it on this webcam or
The phone.
the phone?
I don't know. Show me what they look like.
Okay.
Try it one way and then show me the other.
Okay. So first we have the structure.
Okay.
It's a CubeSat 3U.
Hmm.
It's made of aluminum alloy. It
Okay.
has this little window so we can see the payload inside. The payload for
Okay.
this CubeSat is a mini CNC mill. It has three axes, and the mission is to make a little PCB. It's like a prototype. It's
Okay.
a bit rough, but it works.
Interesting. Now, do you design and build the router?
Yeah, everything.
Everything. Oh,
Yeah.
amazing.
And most of parts are 3D printed, like all the black
Mhm.
parts 3D printed, and
Yes.
just a few parts that were buff, like the
Bolts and
ball bearing, the motors,
Hmm.
etc. But it was all designed by us.
Excellent.
Yeah, it's a bit of a mess of cables, but
wires, right?
yeah, but we can see.
You don't have any PLA printed
No,
stuff, do
it's
you?
all ABS.
Okay.
Yes.
All ABS. We don't like
Good.
PLA.
Aw, poor little
Yeah,
PLA.
we don't like PLA. It's
Daqui que eu botar.
It's great for fidget spinners.
yeah, it is.
Yeah.
Not in the Mojave Desert. They
Oh,
warp, they warp and they don't spin anymore.
Salvador Dali spinners. Yeah.
Yeah. Não módulo da hack. So the payload module, we don't have it now. It's still curing, but we have
Mhm.
the recovery module.
Okay.
Yeah, it's
Better like
better.
that. Yeah.
Okay.
So here,
So that will hold your
yeah,
avionics bay?
no, just the
No,
parachute, the
just a
drone.
parachute. Okay.
This is the coupling tube. It goes inside the payload module. It has more than one caliber. It has like 20 centimeters.
Okay. Very good.
And when the ejection occurs, the payload module and the nose cone are ejected. So now we
Okay.
can proceed with the recovery system.
So for
Separate.
oh, hi, my name is Fernanda. I'm currently the leader of the recovery team.
Okay.
So for the ejection system, we use CO2 based ejection system. We use two of them. Oh, okay. We use two of them, each containing 25 grams of CO2. We have,
Okay.
yeah, this one is empty, okay? It's already used, so it's not dangerous. We use two of them, one here, one the other end here,
Mm-hmm.
and the CO2 goes here. So that's basically it. We've tested it, and it works with both of them activating and with one too. So yeah, that's basically it. So when the CO2 system activates, the nose cone and the payload module will be ejected. Then we go to the next system.
Me dá esse computador aí, Pet.
Then we go to the next system. We are calling it the main release mechanism. It's basically this, a housing and a piston with this,
Access.
no, it's like chain.
Como é que é em inglês e português?
I for liga de. Okay.
Alloy.
Yeah, alloy. And this alloy, so here in this compartment will go the black powder and the matches. And it's secured this way.
Machucou aqui a mão.
Oh, okay. It's secured this way. We use two cords, one in this end and one in the other end, and we use two of them in parallel. So if one of them fails, if the other one functions, it will activate and it will release the main parachute. So that's basically it.
So that's like the tender descenders.
Yeah.
Yeah.
Yeah, but we didn't call it that way because we made some changes and we don't know if there would be a problem regarding the name. But it's basically a tender descender, yes.
Yours looks beefier than the tender descenders.
Yeah.
Yeah.
Looks stronger.
Yeah. So yeah, that's basically. Now for the parachute.
Question. Can I ask
yeah.
a question about that? You said you're using them in parallel.
Yeah.
Did you really mean in series?
No, because if we do it in series, if one of them fails, I don't know which one. I believe it's the one in the top. If the top one fails, then the whole like wiring from the avionics will go up with the main parachute. So it can damage the avionics. We thought of that. One of our members asked me this recently. That's why we don't do it in series.
But if you do them in parallel, if one of them fails, the other one works. Well, the one that failed, because it's a release, it'll still be stuck.
No, because because see, this one didn't activate. There will be like a rope connecting this end with the other tender descender end. This one failed, but the other one worked. The rope will be released. So the rope will still be here, but this rope is not connected to the parachute. She stays here and the parachute will go up. So I don't know if it's good.
I'll believe you now, but can you send me a drawing of how those work together?
Okay.
It's hard for me to get that from the verbal.
Okay.
Yeah.
Okay, let me ask you this. when you set up the system, did you intentionally not release one of them and then see if when the other one goes off that
Yes.
the line and the parachutes actually come out?
Yes,
Not
yes.
just looking at the drawing, but actually putting it on the ground and, okay, this one didn't release. So if this other one releases, will it pull the parachute out? Did you do that?
Pulling the parachute.
Yeah. Did you actually do a ground test to make sure that it'll release and pull out?
Well, actually, the ground test we have made here, we used an anvil, really heavy anvil to end the strings to hold it down. So whenever the system activates, it will drop the mass. So what we did was to intentionally fail with one side and the other activate by itself. So using only one tender, one release mechanism, it was enough to drop the anvil just like we predicted.
Okay. Well, I know one of yours, if you test one of them and it releases, it'll come apart as predicted.
Yes.
What I'm asking is when you had two of them together on the ground, you don't have to use the CO2. Just if you have both of them in how you're going to do it, and purposely don't release one of them. When the other one releases, will you be able to pull out the parachute?
Yeah, we did it.
Okay.
We did it.
Okay,
Yeah.
because that's what you need to make sure. Drawings,
Yeah.
designs are one thing, but actually building it and testing it. If one fails and the other one releases, will you still be able to pull the parachute out?
Yeah, okay. Yeah, we did it. We
Well,
did.
yeah.
Okay.
Was that one of the tests that I saw in the video? I saw several with the anvil
Yeah.
dropping.
Yeah.
Clever idea. Was one of those with both of them together? I
What?
didn't. I wasn't. Was one of those using the two in parallel?
Yes.
Yeah, all of them
Or
were.
and all of them were. Okay,
Yeah, all of
I'll
them
go back
were.
and watch those. Yeah.
Okay.
I didn't look closely enough.
We can show it later here.
Yeah, we can show it
We can
here.
show you later. We
If
have
you
the
wish.
video. Okay.
Okay, yes. That'd be fun. A movie.
Okay, now for the parachutes. We have the drag parachute. It's semi-elliptical and it's made of ripstop nylon. And okay, yeah, you can open it. It has 30 meters per second. The descent rate, sorry. The descent rate is 30 meters per second. And he's connected to the main chute.
Which is this one.
Which is this one, yeah. He's massive. I will try to open, but I don't know if the camera will. Yeah, okay. It's also semi-elliptical and made of ripstop nylon. And its descent rate is 8 meters per second. Wait.
Okay.
Okay. It's 8 meters per second and 30 meters per second. And for the anchor, the shock cords, in our report, we put that we would use Kevlar cords. But after talking to some students from other teams that we have connections, and after doing some research, we found out that there is a better cord, a better option. And we've bought it. We're going to use now
Tubular polyester webbing.
tubular polyester webbing. Yeah, thank you. Tubular polyester webbing that handles 22 kilonewton shock force. And yeah, that's basically it.
Okay.
I'm not forgetting stuff.
Yes. Would you send me the specs for that stuff, or at least the name, so I can look it up? Because I'm not familiar with that cord.
Oh, okay. We can send it to you later.
I love that.
Sure. Yeah.
Yes. Thank you.
Okay. I think for the recovery, that's it.
Well, no, I have
Do you
another
any
question.
questions?
I have another question. On your CO2 deployment,
Yeah.
We've used different methods of CO2 deployments in the past, and I don't like it because a lot of times they fail. So here's a question for you. How many times did you test your CO2 system?
A lot of times, actually. We used to test it last year. The system it's the same. We didn't change anything. Last year we used to test like two to three times every month. And for the IREC, we tested it like 7 to 8 times, and it failed once. We tested it, and only one of them activated, but it was my fault. I didn't. It was my fault because I didn't fully tested the CO2 cartridge. Like it was up here, and we need to fully fasten it. So it was my mistake. It was my fault, and that was the only time that it failed.
Is that on your checklist to make sure that it gets
Yeah.
screwed in? Okay.
Yeah.
Whenever we use things on our big projects, it had to pass 10 out of 10. If it was 9 out of 10, then we had to reevaluate it and do another 10 out of 10. But it sounds like you've done at least 10, and you know why the one failed.
Yeah, yeah. You already know why it failed. So
it was operator failure. Okay.
Yeah.
Okay.
That's it?
Yep.
Okay, thank you so much.
Yeah, for me too.
So for the next part is the avionics module. But first, for that, I want to talk about our coupler system that we talked about in the technical report. We have the pair, a male and a female. For the joint, we just put the two together. They have a little opening here. We insert our nylon. It's a nylon wire. Yeah, it's a nylon wire. It's a square profile of 3 millimeters. And we put it here in the opening. And I'll put it won't let go. Like, not at all. The system is based on ROV, offshore drones used for offshore.
things.
Yeah, offshore things. And we developed this system back in 2022. We tested and evaluated at Latin America Space Challenge 2022 and 2023. It didn't fail. It's pretty amazing. It's
Strong.
Yeah, it's pretty sturdy, strong. And we have a little
Lock.
Yeah, we have a little lock here that doesn't allow the pair to rotate. So it stays put.
Yes. Question.
Yeah.
When you attach that to long tubes, does it have any flex when you bend the tubes?
Not at all. It was machined in a CNC lathe. And was machined in a CNC lathe. I was with the team back in the machining. I was looking over their shoulders like a hawk because we wanted to be perfect fit, and it doesn't have any movement at all.
Okay, good.
Okay, help me out on that. Is that going to be a coupler for airframe?
Yeah.
Yes.
Okay, Jimmy, is there something that says it's got to be one caliber, or is there an exception for machine parts?
Yeah, we researched it. I don't remember I think there is an exception. I really don't remember by head now.
Well, my understanding is that rule was for couplers that were intended to separate. They're simply held together by friction and maybe a shear pin or two. Whereas if something is bolted on, but I stand to be corrected on that.
Well, let me ask you this. If the two airframe sections are going to be bolted on that, is the only thing that's holding them together is just that nylon piece of material?
Yeah.
Okay, if you have a less than perfect flight, instead of going up really nice and straight and then it stops and then your parachutes come out, if you have a flight that's off angled and it's coming up like this, right here when it separates, it could be going 50, 100 miles an hour. And there's a whole lot of force there. I don't know if that little piece of nylon is going to retain and hold those things together.
Yeah, we never had a problem during our flights.
Let me ask you this.
Yeah.
When you did the drop test with the anvil, did you also test that nylon thing?
No, we did not, but we
Okay,
made
I
a
would
flight
like
test.
you to, well, pop test is just a ground thing. Okay, once you're in the air, pop test is better than no test, but
Yeah.
actual flight test is the best.
Yes.
I would like you to try that drop test with your anvil, see if that little nylon thing holds things together.
Okay, no problem at all. We had our flight test recently, like 2 weeks, last week or 2 weeks back. And we used this coupler and we haven't had any problem at all.
Okay, but what I'm saying though is if
Yeah.
you have a nice straight up flight
Mhm.
and then gravity stops it and then the parachute deploys, that's fine. But in another scenario, if the winds are blowing and you have a not vertical flight and it comes over the top like this, when it tries to like blow out the parachute, it could be going 100 kilometers an hour. And when that chute opens, there's going to be a really big shock. And so I'm asking if you could test that nylon thing holding the sections together with your drop.
We can.
So there's more force than just two of you like trying to pull it apart and well, it seems strong enough.
Yeah. Yeah, it's better. Okay, we'll do it. No problem at all. We're going to try to make this week or maximum next week and record everything and send to you for evaluation.
Okay, sounds good.
Thank you. So now we're going to the avionics module.
Good afternoon. My name is Leonardo. I'm the avionics base leader, and I'll show you the system we're using today. For start, we're using three phenolic plates with one like this one. This one is for data collection, and they all passes through an RBF to
micro switch.
No, to turn it off, to turn off all the connections. Right now it's a bit messy, but it's just because we were testing stuff and didn't had time to unscrew everything and make it clean. But we had rerouted all of the connections and we are going to make this a little bit cleaner for the flight. So this one is the RRC3 plate. We are making it an a phenolic plate for I don't know, it's CNC too. Yeah, it's machine too. We have
a mill, milling.
Miller. We have a mill that will manufacture the plate. This one is just for testing, but it will be brought to US to flight as well. If the other one makes any failure, and that's it. This one is the telemetron. And the telemetron itself has a antenna connection, so we will wire this little guy here on the antenna that I'll show you now.
So this is our antenna.
This is our F antenna. It's made like this because of the ground, and this ground make sure that we don't connect it to any aluminum foil or anything. And the connection is through here, and it goes in there, as you can see. So we connect it to the telemetron, and it's all done. I think the avionics bay is this. If I have any questions.
Yes. Can we go back to the other bay, the electronics part of it, and look at that? I want to look at the battery holders. Are those the ones you plan to use in flight?
No. It's we will change those. Those aren't. This one is also broken. Because of the test. This one is very cheap ones, and it was just for testing.
Okay, good. Those are not adequate for flight.
No,
especially not that one.
Yeah, especially not this one. And we had made sure that this is changed. So we will have a 3D printed holder that will hold both ends of the battery, and we will solder it on the plates and everything.
Okay. Very good.
I forgot to mention, but these ones are here we have the connections for the recovery system. So we have boards here to hold the cables, and on the other hand, on the e-matches, we will crimp the connections for not just make a connection and use sorry, I forgot the name of the tape. The
electro tape.
Electric tape. So this is it.
So you use the mechanical crimping sleeves with the pliers to make that connection?
Yeah.
And then tape it up.
Yeah.
Seems like I've seen something recommending against the use of electrical tape in altimeter bays.
Sorry. I haven't made myself clear. We are not using the electrical tape. We're using a crimping system that shall glue everything together, like press against each other, and it will make it tough and safe.
Okay. Good.
Okay.
Yeah. As long as it's very secure and well insulated.
Yeah.
Okay, I have a question. Can you bring back your avionics bay?
Yeah.
Hold it back up. Okay, one of my pet peeves is you pay a lot of money for the electronics, and yet they're bare bones. It looks like you guys know how to 3D print some really cool stuff. So I always tell my students to 3D print some kind of case so that your electronics aren't.
Yeah. Okay. So we now just have to wait for Rick to join again.
Yeah, I'm in no rush.
Yeah, sorry for that, Jimmy.
Well, while we're waiting for Rick and your advisor to come back, you're using micro switch switches.
It's right here.
Munismo, passa minha mochila. Aqui tem RBF preso ali fora.
They're just here. Those are the micro switches for the RBF. Okay.
Yeah.
I'll uncouple it. Just a second.
Okay.
It's actually this little guy here. As you can see,
Oh, there. Yeah.
Yeah. In here there is 3 micro switches, and we have a total of 6 to turn off all of the electronics and pyro batteries.
Yes.
We choose to make it splitted, so we could turn off only the electronics and or only the pyro batteries for testing and stuff. So we use this and the RBF and the little key.
Yeah.
So I'll couple it and
Hello, Rick.
hello, Rick. Sorry.
So yeah, that's okay. That happens.
Yeah. Well, yeah, we might want to pull that out and show it to Rick too, because that's sort of what he was talking about a minute ago.
So I was showing to Jimmy the micro switches. We use the micro switches down here, and we have the yeah. I just had to. No, it's okay.
Okay. No,
guy to make the micro switches fixed, affixed on the structure.
No, what I'm talking about is the bare bones circuit boards. When you buy a cell phone, does it look like that?
Yeah.
When you buy a TV, does it look like the circuit board stuff is visible, or is it in like some kind of protective case?
Of course.
Yeah.
Because we've had some rockets where they have crashed, and they're trying to figure out why they crashed, and we're like trying to like look at the pieces as we pull them out, and occasionally we'll see where somebody was clipping a wire, and that wire went flying into a circuit board, and when the rocket is jiggling around in flight, it shorted out the board, and so that's why the thing didn't. The thing stopped working, it crashed.
Yeah.
So I try to tell teams, especially if they're able to 3D print like a little enclosure case for their electronics, put holes in it for the wiring. And if it needs to, like for a barometric, and if it needs like to measure the air pressure, then you have some holes in it, but not leave the whole circuit board just exposed.
Okay.
So that's just something that I tell all my teams.
Oh, okay. We will work on this to show to you later. We have to sit and discuss about what we can do, but this is just for demonstrating. So the wires are messy by fall, but we will discuss this and make the changes to make everything very tight.
Okay, well, I'm not necessarily, commenting on your messy wires. I'm just mentioning, bare bone electronics. Usually they get protected. Like in your car, is it all exposed on your dashboard, or is your dashboard?
No. Yeah, I get it.
All right, and it's up to you if you want to do that or not. But I saw the great 3D printing you guys were doing, so I thought, well, they should be able to make a case. One other thing, like on your batteries, I know you said you're going to redo the battery holder.
Yeah.
You have 2 bulkheads, and where you mounted the batteries, you mounted them so they're in between the bulkheads. I usually tell my students, move the batteries against one of the bulkheads so that the bulkhead helps support the load on the battery.
Okay. Do you want to answer about this, because you're best at 3D printing than me?
Yeah, I'm the 3D printing guy of the team. So I don't really get it what you said, Rick. Can you repeat? Because
okay, let me get this out. Okay, this is what I see in your avionics bay. I see a bunch of just bare circuit boards with wires connected to them. Okay, and if you have anything loose or like a clip piece of wire, that's inside your avionics bay when the rocket's flying and things are bouncing around. That little wire hits something, shorts out the board. So I have my students make like an enclosure, and the circuit board fits in there. Or if in your case, if this is mounted in your rocket, then make the closure so that it fits over the top like that. And so this is like what you have. You know, it's kind of protected, just like your cell phone. Your cell phone doesn't look like that, does it?
Yeah, no, not at all.
Your cell phone has a case like this where you start talking. Anyway, it's up to you. I just my own teams here in the U.S. I talk about them doing that, and then this cover right here just fits right on there, snaps on there, and the whole circuit board is enclosed, except places where the wires come out, or if there's a light that you need to see the light blinking. Anyway, just a thought.
No, yeah, it's really good. It's a really good feedback. We will work on this.
Yeah, we can make it. And I have a question about your suggestion of the battery holder. I didn't understand what you said to press against the battery.
Okay, imagine this is one of your bulkheads, and this is the other bulkhead.
Yeah.
Okay, you have your battery holder mounted like this inside, versus if you mount your batteries so that they're resting on one of the bulkheads, that's added support for the batteries instead of the batteries just being screwed or glued on in between.
Yeah, I got it.
I think I can show you a picture of this idea, because we will make this bulkhead. It will be like a sleeve. It will be like this. The battery get inside, and on the other side, it's like that too. So it's not just resting; it's hugging the battery. But I can I have a photo to show.
Yeah, I was just Jimmy mentioned a battery holder that you were using, and so I just wanted to throw that in. We have some students that do 100G flights, and if you have a 1 ounce battery in a rocket that's doing 100 Gs, that battery is acting like it weighs 100 ounces, and so they really have to make sure that their batteries are secured.
And
okay, if you want, you could send that to me so that you can continue with this. My class is going to start here in a few minutes, so that's the bell.
Sure.
Okay. For the avionics bay, you guys don't have any other questions. I just forgot to mention the receptor antenna will be a Yagi antenna, and you coupled with the tele-BT of the telemetrum, and that's it for our first collection of data. And if you guys don't have any questions, I'll move further.
I'm still going to have this on, but I'll be away from the camera. I'll still try to listen, but I have students that are going to be cutting carbon fiber tubes and fins.
Okay.
Sounds like fun.
Yeah.
Yeah.
So they're wearing respirators.
Yeah.
Okay. Into the class.
Important. So for the next part, we will talk about the propulsion.
Say, Mike.
Yeah, propulsion system and propulsion module.
And part of the aerodynamics too. So it's me again, Lucas Paredes, and talking about propulsion, I'm going to start with the bulkhead that is made of aluminum, is 6351 series of aluminum. It has 4.5 inches, and it has 14 screw holes and 2 O-rings here to seal everything. So after that, we can talk about the casing of the motor. It is made of aluminum too. It is Series 6 too of aluminum. And an important part of that is that the nozzle, when in bed here, it stick it here.
Yeah, it never worked as intended when we're trying to show.
Okay.
I get the point,
You
I
get the
believe.
point. Your
throat will be inside the motor case.
Yeah,
is that?
Yes, that's good.
the throat is inside the motor case.
Yeah.
Very pretty nozzle, by the way.
Who
Who did the machining on that?
Yeah, I was there too, like the couplers. It's
So that's the nozzle. Is made out of stainless steel, 304 stainless steel, and it's the same thing as the bulkhead. It has 2 O-rings and 14 screw holes. It has a 27 millimeter throat and 3 millimeters depth of throat here. And in the end, I don't quite remember.
Yeah, neither do I.
So after that, we get to the talking about the module.
Oh, I missed the nozzle.
Talking about the module.
You can see it back there.
What?
Sorry, what?
Rick wanted to see the nozzle.
Okay.
Yeah, I missed the nozzle. Can you hold the nozzle back up?
Yeah, bring it back.
Okay, very nice looking nozzle. You guys machined it, or did you have it machined somewhere else?
Yeah, we in somewhere. Yeah, it's a bit of
both.
It's a bit of both. We machine it somewhere else, but like the couplers, I was there looking like a hawk over their shoulders to make sure that it's perfect. It was also machined in a CNC lathe.
Okay, cool. Thank you very much.
Yes, beautiful.
So,
okay,
talking about the propulsion module, we have this one right here. And the motor is centered right here by this that goes inside here.
Okay.
And
the motor goes inside here, and it's inside the module is our centering ring mechanism. We have these little gaps here, so we can push it, and it doesn't stop
with the rail button.
Yeah, it doesn't stop in the rail button.
Rail button. Okay.
I think talking about propulsion, this is everything. But just to finish, do you have any questions about the propulsion?
Well, that rail device, the centering device you had, looks like the nuts aren't tightened very much on it at this point. Is that important?
Yeah, when we are using, we
fasten it a lot.
Yeah,
we put like glue. What's the name? Aquela cola de thread. Português para.
Sei lá.
Nut glue.
Thread lock?
Yes.
Yeah.
Thread lock.
Yeah.
Thanks.
Okay.
We put thread lock here.
And when we are using, it's very stable. Right now, it's
just floppy.
Yeah, it's losing
because it isn't mounted like fast enough.
Right.
We just mounted to show you.
Just to show.
Yes, good. I just wanted you to know that I thought that was important, but you already knew that, I'm sure.
Yeah, no, it can't be that loosey.
Yeah, no.
Yeah.
And now we need to talk about the aerodynamics.
Okay.
So here we have the fins of the rocket. It's pretty strong.
Can you wobble them any?
If you want
no, not at all.
Nothing at all.
Good.
That's really
sturdy.
really tough one. It's made of fiberglass, 6 millimeters thick, and yeah, about the things, that's all. And just to the end of part of the rocket, we have the bolt tail that is made of carbon fiber.
Okay,
That's the bolt tail.
good.
That's one that's painted. That was used during the test flight, the flight test, sorry.
Good, good.
This one is for IREC.
Okay, very pretty.
Thanks. I think talking about propulsion, that's everything, and aerodynamics too.
Well, there are a couple more parts I think you have not shown me. What, isn't there a thrust plate and a motor
Oh,
retainer
the thrust
at
point.
the aft end?
Okay. Esse aqui com o centralizador.
So, in the thrust point is this right here. One of the couplers and a centralizing piece that is made out of nylon. It centers here in the it centers here in the aluminum casing. Right here. And after that, it opens here and we screw it. Okay?
Okay, then that will go in the airframe.
Yeah, and these go into the airframe with the centralizing piece too. Those one here.
Okay.
That stays here in the segura com o motor, por favor.
And I see screw holes, so that will be bolted into the airframe.
Yeah.
The aft part, I mean.
We
Oh,
use,
so you're gonna install that on the motor and then put it in the airframe?
sorry, what?
So it just occurred to me you plan to put that on the motor and then put the whole assembly in the airframe. Is that
Yes.
correct?
Yes, yes, yes.
Okay.
Yeah.
Yeah.
We put the motor and then we put this part.
Yeah. And we use the bolts in the airframe, the same bolt that locks the coupler in the airframe also lock this nylon piece here. So we make sure that it's not moving at all. The same set of bolts can secure everything in place.
Is the nylon going to impinge upon the nozzle
No,
No,
or any other hot part?
no.
no. Against the nozzle, cadê o tubo aqui? Me dá me dá também o bucheio. So yeah, in the nozzle we have this that's our boat tail shoulder. The boat tail goes right here, and this part we bolted in the airframe. The nozzle stays put right here.
Okay.
So the motor can't leave the rocket.
Stays in place.
Yeah,
the
stays
entire
in place. And
Okay, good.
the ends of the nozzle, it's aligned with the ends of the boat tail.
Very good.
So, from the propulsion part and the aerodynamics part, I think that's all. Do you have any questions?
Yes. I know that you did some work with the getting your off the rail velocity up a little bit. It was kind of low when we first started.
Yes, we were.
And yeah.
Talking about the ignition part of the motor, we changed it
Right.
a little bit. We started using
An
igniter that is like 5 E-matches, one for each segment of the engine. And all of these E-matches were with a little bit of gunpowder.
Yeah, I have a video here that I can show it.
And we have this video of the igniter right here.
Oh, wow.
That's kind of strong, I know.
Yeah.
So you're going to have a linear ignition through the motor.
Almost linear.
Okay. Have you tested that in a
Yes,
static
we
test
tested
yet?
that in the test of flight. the flight test.
Oh, excellent. Very good.
And our rail exit velocity in the flight test
Was about 30 meters per second.
yeah,
We almost doubled it.
the minimum. It was around,
Very
yeah, it was around 30 meters. The minimum is
It's
15.
So we doubled it.
It
Okay,
was
what is your-
actually, sorry,
What is your current number you said on the rail exit
Now it's
velocity?
30 meters per second.
30 meters per second. Okay,
Yes.
that's very good.
it was faster than the simulation, actually. The simulation
Yeah.
was around 25.
526.
Yeah, and the real one was 30.
That's much better.
Yeah.
Well, we have another little possible wrench to throw in your works. I don't know if I was aware of this when we talked before, but there's a new method of estimating the rail exit velocity, which does not take into account, not use the total length of the rail. It takes the length of the rail from the forward rail button to the end of the rail. And that makes your effective rail length a few feet shorter.
Okay.
Were you using that calculation when you did the
Our
rail
rail
exit?
button is like really down there. Like it's around here. Our rail button is right here. So it's
That's
kind
your
of
forward rail?
yeah.
Yeah.
Oh, but there's another one.
Here and
One here
another
and
there.
another one here.
Okay, so that's your forward
and
rail.
Yeah. This
And
one.
is there a third one, or are you just using those
Just
two?
two.
Just two.
Just two. Okay, well, you're Well, I think the rule still holds. You have a lower forward rail than most rockets of that size do, so that's not going to reduce your rail length that much, but it will do it some.
Yes.
And what I'd like is hold that aft end up again if you don't mind, so I can see the rail buttons. Is it still there where you can hold it up? And
You want to see
Okay,
just the rail
so-
button?
yeah, the forward rail button is where? Well, yeah, that's the good rail button. Very nice. Now, are you making those yourself?
Yeah.
Yes.
Okay, good.
Machine.
And they're machined. It's not 3D printed,
Yeah,
right?
machine.
Machine.
Yeah, good. Because 3D printed doesn't work on those, but it looks like they're good to go. But I want to see the distance from your forward rail button to the very aft end of your rocket or the
Okay.
motor tube. And that will probably include the tail cone.
So yeah, should do this.
And just know what that distance is.
So the most forward one is this one, right? And the
Okay,
end is right here.
Yes, but it's not that counts. It's where the rocket will be sitting on the rail.
Oh,
And
okay.
it's not gonna be sitting on that middle rail button, the lower rail button. It'll be sitting on the aft end of the rocket.
Yes.
Okay, we have a technical drawing of the rail button position. I
Okay.
can send you later, but the distance between the lower rail button and the end of the rocket is around 40 centimeters.
40,
Centimeters.
46.
No, 40 centimeters, 400 millimeters.
Oh, 400 millimeters.
Yeah,
Okay,
yeah.
good. Yeah, well, you would just subtract that from the 17-foot length of the rail.
Okay.
And that's the length that you would use. So I can't convert metric in my head, but whatever 17 feet is in metric.
I think it's around
520 centimeters.
Yeah, it's around
So-
5.7 meters.
Yeah, so subtract that 400 and use that in your simulation
Okay.
Okay, fine.
and see where it's at. Now, since you're up to 30 meters per second off the rail now, I think you'll still be fine.
Okay.
It's just when you get to the IREC, that's what they're going to ask about. They're going to ask if you have done that rail
Okay.
estimation. You got it.
Okay. Okay. Yeah, is there any other question? We hadn't make ourselves clear about any topic.
Well, you've done very well.
Thanks.
Thank you.
Thank you very much.
I had to work very hard to find any suggestions to make and didn't find anything of great consequence. There's one more thing I'd like to mention. It's about the altimeter bay and the micro switches that you're using.
Yeah.
I was at the NASA student launch here a couple of weekends ago, and one of the reviewers looked at the use of those switches and had a problem with it because he said that, you know, those micro switches are rather easy to actuate, right? And that's one of the reasons they call micro switches. They come on and off rather easily. And if they're oriented vertically, where the lever is up or down, that means there's some potential for them to be actuated by a sudden movement of the rocket, either up or down. And you know what? Rockets move suddenly,
Yeah.
up and down. And just a few days ago, Rick and I had a conversation with another team that had a failure in flight, where they had an anomalous ejection at apogee and a lot more velocity than they had expected, and the altimeters turned off when the ejection happened. And they were using that same kind of switch going back and forth. So we have a strong suspicion that that fear might be true, that they might be subject to actuation from velocity change.
Okay.
I don't think you need to change your rocket now. I think you're okay with that. It's just something to think about. Now, one of the reviewers at NASA suggested you lay them on your side, on their side.
Yeah, we can do it. It's no problem at all
You've
to
already
change
made your
it.
device. It's fine like it is. So that's one thing to do. Something that I've done, I didn't have this in mind when I did it, is you can take the lever off those switches, or you can buy them without the lever, and then you only have that little pin button to push in, and it has a lot less mass to it.
Yeah.
Now that would mean redesigning your switch base, so don't go to that trouble unless you just want to, but those are just two ideas for the future.
Okay. Okay.
Thanks.
Thank you.
Thank
Thank
you.
you.
It's a great point to have in mind.
Yeah.
Yeah. Well, I'm looking forward to hearing back from the other team and see what their analysis was, because there's some other reason they might have had a failure. I don't know if they can really determine if that's what happened or not. But what I might do in the future is do some drop tests on it. And that's just to make up a board with a switch on it, a battery, and a light, and drop it and see if the light goes out when it hits the ground.
Okay. Yeah, it's a nice test.
It's a good test, yeah.
Cheap and easy and kind of fun.
The cheaper and easier, the better.
Yeah.
And the more fun, the better.
Yeah.
That's why I love your anvil tests. Those are great.
Yeah.
I love the sound of the anvil when it hit the floor.
Yeah. Me
Nice
too.
ring.
Me too. It was awesome.
Yeah. Well, any questions for me or comments or rude remarks?
I do have a question regarding propellant. In the US, we will get in Texas earlier, the competition like 1 week earlier to make our propellants.
Okay.
Is there any laws or regulations regarding the transportation? It's any specific methods of transportation? We have to put it in a box, label it, like signalization, any kind of things like that?
Well, you first off, obey the law. Don't speed when you're driving, or you'll get stopped. Okay. There are laws about that, but I'm not an attorney and can't really tell you which ones would apply. Some students, some teams are being careful and they're having Rick transport their propellant. You might ask him if he's willing to do that, because he has a license to do so. So it's obvious he has clearance.
Okay.
Whether you or I have clearance is questionable. So I would suggest get him to do it if you can.
Okay.
Okay.
Yeah.
He's a licensed pyrotechnic operator, so he's authorized to transport such things.
Okay, thank you.
Yeah.
It's just like that? Just this?
Yeah.
That's it.
I think for now we don't have any more questions.
Yeah.
Not that we can remember.
Well, come up with some, or if you remember them, let me know. I'd love to continue our conversation.
Okay.
We just received a message here in meeting that our meeting time is nearly over again.
Oh, okay. Then I can go bye-bye anytime.
Yeah.
Yeah.
Unfortunately.
Is there any more questions that you had?
Not
No?
yet. I'll email them to you if I get some.
Ok.
Okay.
A gente tem que mandar para ele as coisas.
So
We'll send to you later the videos of the testing and the drawings about of.
Okay.
Okay. Can it
Yes,
be
thank
by
you.
mail?
Yeah, email's good.
Okay.
Oh, thanks.
Excellent.
Thank you.
Well, thank you so much. This has been fun. I'm honored to be able to work with you.
No,
Yeah,
as
of
we,
course.
yeah,
Yeah.
it's really an honor to meet you finally. I've been talking to you via LinkedIn a lot, but it's nice to finally meet you.
Excellent. Me, the same here. Let's continue. And maybe I'll see you in Texas sometime soon.
We hope so.
We hope so.
Yeah.
Excellent.
Thank you,
Excellent.
Jimmy.
Well,
Thank you
how
a
about
lot.
here's a little bit of Florida for you.
Oh,
Yes.
Oh, that's a nice view.
Yeah, it's a really
I
nice
get,
weather too.
yes, it's nice here now.
Yeah, the window is really far away from the computer.
the computer.
It's okay.
And the room is messy.
Yeah, but we can send you also a photo of our view
Oh.
later.
Yay, that'll do. That'll be fine.
We have a really beautiful picture testing the antenna. So we can
We're gonna
send
send
you,
you.
yeah, we're gonna send you.
Yeah, it's a really beautiful
Okay,
picture.
great.
The Maraca.
And thank you for that static test video. That was beautiful.
Thank you.
I've watched it over and over again.
Thank you.
Thank you.
All right.
So I
Okay,
think
I'm gonna
it is.
ready to go bye-bye.
Bye bye, Jimmy's hands.
Bye-bye, everybody.
Bye bye,
Thank you
Jimmy.
so much.
Thank you.
Thank you too.